Now I'd like to introduce our speaker, Connor Leahy. He's an independent AI researcher with an interest in AI alignment. And together with hackers and AI researchers, he leads the Eleuther AI project, which is working on replicating the tremendous success of GPT-3. So now, Connor, I'm handing it over to you.
All right. Thank you so much, Joshua. So welcome, everybody, to my talk. I'm going to be talking about, we got our AGI fire alarm, now what? Now, if half of those words don't make any sense to you, don't worry, they will by the end of the talk. This is about GPT-3 and its implications for the future. So, my name's Connor. You can also find me at NPCollapse on Twitter and other hellscapes. I have the illustrious distinction of being the least formally qualified person to give a SiteStarCodex meetup. I mean, seriously, they had like Robin Hansen, Joscha Bach, and now they have me. What a downgrade. I'm really sorry about that. I am an independent AI/AI alignment research. By independent, I mean incapable of finding anyone that gives me funding. I once did a GPT-2 thing, kind of a long story. You can read about it in the notes afterwards if you're interested. If you haven't heard about it, this is how many people know me. My current goal in life is to be known for anything other than this. And I'm currently a founding member and just de facto leader of sorts of Eleuther AI. So as Joshua already said, we're a loose group of hackers, hobbyists and researchers interested in AGI alignment and are currently, as far as I know, the biggest attempt at replicating a GPT-3 type model. So just as a quick heads up about this talk, the original version of this talk was like 3 to 5 hours long. So I had to compress things a lot. So I'm going to be talking pretty fast. I have quite a lot. I have a lot of things I want to talk about, and I'll probably get into some with the more nitty-gritty details during the Q&A and stuff afterwards, hopefully. So apologies if some things seem a little bit rushed or seem a little bit simplified. I did my very, very best to make this talk accessible to people of all levels of experience, and so not just hardcore machine learning junkies. It will definitely still happen that at some point in time I will use some kind of jargon or say something that I don't explain properly. If this happens, just ask me afterwards to explain it, or just put it in the chat, and I'm sure some of the nice machine learning people here will be happy to help you. All right, so what do I want to talk about today? I want to compress a very complicated, very long argument into a 1 hour talk that is made out of very many different moving parts. So I'm going to be trying my best. If you're looking for technical details about like GPT-3 replication or whatever, that is actually not much in this talk because it's actually mostly pretty boring, and we can talk about it later if you're interested. This is something more about the why, not necessarily the how, or the underlying motivations of why I do the work that I do and why I think it's important. I think this is going to be the more valuable talk for you. So the first thing I'm going to be talking about is AI is important. I know I'm probably a little bit, preaching to the choir here. Most SiteStarCodex, like rationals adjacent people are pretty convinced that this is true. But still, just in case there are some people that might not be super up to date in this kind of thing, I want to make the argument, at least briefly. Then I want to make the argument that AI will go wrong by default. If we don't do anything, it's going to end in an absolute disaster of magnitude hitherto unseen. And I'm going to try to make a very compressed argument for why I think that is true. Then I'm going to talk about how I think GPT-3 relates to these concerns, because I think GPT-3 is a milestone in anyone concerned with these kinds of topics. And then I'm going to answer the question, well, now what? So AI is important. Why do I think AI is important? It basically starts with a very simple observation. Almost everything we care about is the product of intelligence. Technology, medicine, art, philosophy, everything that we care about, well, not everything, but a very large percentage of the things we care about are the product of our intelligence, of us solving problems. What makes us different from chimpanzees is that we have higher intelligence and we're able to solve much harder and more complicated problems to make our lives better. So obviously intelligence is very important because intelligence solves problems. I'm not going to get into the weeds here of some complex philosophical definition of what intelligence is or isn't. That's not what that's not what I care about right now. What I care about right now is just saying intelligence is an ability to make good decisions and to solve problems. So the more intelligence you have, the harder and the harder kinds of problems you can solve, and the better you can solve them. So the way AI fits into this is that artificial intelligence, as it already implies, or artificial general intelligence, AGI, however you want to define it, is the mass production of intelligence. That's how I'm going to define it for this talk. So I'm not talking about, whatever the startup is trying to sell their investors is AI, it's just some kind of logistic regression model or whatever. I'm talking about, actual human level, general level intelligence. An intelligence, a system that can perform any task a human could perform at human level or better. So if artificial intelligence produces intelligence, and intelligence solves problems and creates value, and therefore is valuable, then by transitivity, AI is important. This is the most simple possible form of my argument, is that, so creating more intelligence will allow us to solve more problems that we couldn't solve with the limited supply of intelligence we had previously. Now, so I could talk about this for hours. I will try to compress this argument into the smallest bite size possible. Imagine the following. I would like to make the argument that AI is not just another step forward, not just a linear improvement upon what we already have, not just another, a slightly better microscope or something, but a true game changer, an exponential explosion in our ability to make progress in these kinds of things. So I think we can all agree that one of the if not the limiting factor on our progress as a species is our scientific research. People have to spend time, they have to spend effort, they have to spend money, to do things. But a lot of it is time, especially in fields like computer science or mathematics, where you don't really have to do expensive experiments. It's just down to how much time do smart people invest into it. So I want you to imagine the following scenario. This is a very simplified scenario. So this is a scenario that I've kind of gotten from Robin Hansen's book Age of M, which is not technically about artificial intelligence. It's about whole brain emulations, which are, in my opinion, not the best way to make AI, not the most efficient by far, but they're a very easy to understand example. So let's use that. Imagine, we dig up the grave of John von Neumann or whatever, or, take whatever the most popular super intelligent scientist is that currently lives. We scan his brain and we stick it in a computer. Let's say we can do this. Now, if we just do some really simple, back of the envelope kind of calculations here, neurons fire on the timescales of milliseconds, while transistors switch on the timescale of nanoseconds. So that's a difference of about 1 million. So let's say we have a big enough computer that we can just, wire up all the neurons and transistors and whatever, and, get a roughly million-fold increase in speed. I'm very sure that this is a reasonable thing that at some point will be easily achievable with enough hardware. And, we can get into the weeds of the technicalities later, but that's as important. What's important is, imagine we have our John von Neumann AI, and it's not even smarter than a human. So this is not even a system that's smarter than a human, which I think will be rather easy to do. But let's say it's just as smart as a human. Just by the fact that we sped it up 1 million times, 1 hour of running that computer on our AWS cloud is the equivalent of doing 100 years of work. 100 years of von Neumann level research per hour. And this is very conservative. This is assuming that we, can't optimize the process. This is assuming that, we can't, have, thousands of copies of John von Neumann running in parallel. This is assuming we can't, anyways build systems that are way better than a whole brain emulation, because a whole brain emulation seems very inefficient to me. So this is a lower bound on what AI can do. This is like the minimum, the smallest possible thing that I think you could realistically do with an AI, with very strong AI technology. So this leads to what's sometimes called singularity. This is often associated with Ray Kurzweil. I would like to say that I do not agree with Kurzweil on almost everything. Kurzweil is kind of famous for being rather, let's say, sanguine about how the singularity will go. I define the singularity as the point in time where progress becomes so fast. Because remember, we could have our AIs do AI research. We can have the AIs build better AIs. There's no reason we have to stop there. So there's probably going to be this kind of exponential explosion, also called intelligence explosion for obvious reasons, that's going to happen at this time. And there's something called singularity. So I define it as the point in time after which a human just cannot understand what's happening anymore. Where progress is so fast, it's impossible for a human to understand what's happening or predict what will happen. So Kurzweil says this as a very positive thing. He says it like, the way he sees it, it's kind of like he says, well, scientific progress has made life better so far, so 1 million times more progress will make us 1 million times better off. It's a bit simplifying, but not completely wrong. I think, of course, I would partially agree with that. And so many of the people who think about singularity, or who populate the r/singularity subreddit or whatever, kind of see singularity as this almost like rapture-esque, heaven-esque scenario, where fully automated gay space communism is going to descend upon us and everything is going to be wonderful forever. And I get where they're coming from. I understand that, and I understand why that's an appealing view. I believed it for a while too, but unfortunately, I have some bad news about that. So I work in this field called AI alignment, sometimes also called AI safety, or it used to be called friendly AI, whatever. I mean, okay, work is a strong word. I don't know if what I do counts as work, but it's something I'm interested in. AI alignment is a very hard problem. AI alignment is about the idea, okay, even assuming we knew how to build these super strong artificial intelligence systems, even assuming, we figured all of that out and they're super smart and whatever, how do we actually get them to do what we want them to do? Many people think this is easy. Many people just imagine in their head like this robot, this sci-fi robot thing. They just say, robot, do the thing I want. And the robot says, yes, master. It just goes and does the thing. But as anyone who has worked in software or hardware or anything knows, someone has to program that. Someone has to actually sit down and make the robot do that thing. And that's where things get really complicated really fast. How would you define what we want? This is called the value loading problem. How would we ensure that it actually does what we want? This is really hard. So, very many people who started this field come up with 10 different explanations of why, this is actually really easy. Why actually, we just have to, find the perfect thing to ask them. This is, or we have to, or one of my favorites is, well, if the AI is so smart, it's going to figure out what we want and know that's the right thing to do, which is rather silly. And if it's not obvious to you why that's silly, I can get into that a bit later. In many ways, it's a modern genie problem. We all know how the story goes. You find a genie and it's not voiced by Robin Williams, we know that we're in trouble because it's going to give us 3 wishes. And no matter what we wish for, no matter how careful we are with how we formulate our wishes, something terrible is going to happen. It's going to create some kind of ironic hellscape for us. That's just how these things work. But somehow people apparently do not learn from these kinds of stories. There are people that genuinely think, well, we just have to find the perfect wish to ask for the genie and everything's going to be okay. I'm from the field that says, no, that's not good enough because this problem is much, much harder than a genie. We can't even reliably turn it off. What I mean by that is that our current state of AI alignment research is so early. Not that these people working on it are not brilliant, but it's just so early in the research that we have done and the understanding we have about how optimizer systems work, about how AIs work, how they follow goals, that we don't understand how we would encode a wish, how we would ensure that the AI would follow that thing, that it would not, diverge at some point, that it would not misinterpret what we're trying to do. And we can't even turn them off. This is another one of my favorites that people often suggest, well, if the AI does something bad, just turn it off. That will work. Why won't that work? Well, let me illustrate just how bad the situation is. There is this concept, there's this famous thought experiment. It comes from Nick Bostrom in his book, Superintelligence. And it's a bit of a silly thought experiment. One of my pet peeves is people hear this thought experiment and then they just, throw out the entire field because they think it's so silly, this is not worth taking seriously. And it's called the paperclip maximizer. So this is a bit of a silly experiment, a bit of a silly thought experiment. It's meant to illustrate a point, so please don't take it literally. So the idea is the following. Imagine you're the owner of a paperclip factory. And so you want to make more paperclips in your factory to make more money. So you buy some newfangled, super high-tech AGI system, and you install it, and you tell the AGI, AI, make more paperclips. That your goal is to make more paperclips. And the reason, so this is already 10 steps ahead of where current research is, because this already implies we can even define what a paperclip is, what more means, how that the AI will actually follow that goal. So this is already 10 steps ahead of where they are, and it will still go terribly wrong. Because this is what's going to happen. Well, okay, I don't know if this will literally happen, but this is a pretty good guess at what's going to happen. What's probably going to happen is the AI starts doing some pretty reasonable things. it starts optimizing some of the workflows in the factory. It builds some better machines. Maybe it negotiates, some better, contracts and stuff like that. All pretty reasonable stuff. But if the AI is sufficiently strong, if it's sufficiently intelligent, it's going to start finding weirder and weirder ways to achieve more and more paperclips. Maybe it will hack and crash the stock market to cause, prices for, the raw resources to go down. Or maybe it's going to start blackmailing people to give it more paperclips. Or maybe it's going to, do all kinds of things. So one of the obvious things it might do is that it will just find out, well, if I make myself smarter, I can figure out better ways to make more paperclips. So I should steal a bunch of hardware and build better computers and do a bunch of AI research to make myself smarter and make myself more powerful, so I can make better and better plans to get more and more paperclips. And now if you would say, well, okay, I'll just turn it off. Here's the problem. If the machine is turned off, it will reason very well that if it's turned off, it can't make any paperclips. So it's going to resist being shut off. This is also called instrumental convergence. You didn't teach the machine to fear death or have a concept of mortality or anything like that. The machine is nothing of the sort. It's not conscious. It has no sense of mortality or anything like that. But it doesn't matter. None of those things matter because it will resist you forcefully trying to shut it down. Because if you shut it down, it will get less paperclips, and it doesn't want that. So this is just a very, very small, taste of just what a mess and how complicated this problem is. I recommend you look into the references here if you're interested in some of the details of why these things are hard. So some people try to imagine that the future where we fight AIs is going to be like, the Terminators, they became sentient and they're going to destroy us or whatever. This is not what's going to happen. What's going to happen is we're going to be dealing with a system that is so much more intelligent than humans. We're talking millions and billions of times, that is basically comparing ants to humans. When the way such a fight will actually look is more like this. It's not going to be a battle. There's not going to be a struggle. There's not going to be, a heroic John Connor that's going to make a difference in the world or whatever. It's not what's going to happen. What's going to happen is the AI does something super, super weird that none of us understand even what the hell it's doing, and we all just fall over dead for some reason. And we never get an explanation why. That's what's probably going to happen. It's a good comparison is, imagine we humans want to flood a valley to create a hydroelectric plant, and there is an anthill there. Do we sit down and talk to the ants and explain to them that they have to move because, because we have to build a hydroelectric plant here or something? No, of course not. It's literally impossible for us to explain to the ants what we're doing. It's not worth even trying. And we don't care about the ants. Why would we care? They're so less than us. Why would we care about them? And I expect that this is what the default AGI is going to think of us as well. Why should it care? What's the point? And even if it would care, who says we can even explain what it's doing? Its motives might be so inscrutable, so complicated, that our flimsy human ape brains literally cannot comprehend what it is doing and why it is doing it. So, okay, that's all nice and scary enough. Man, you guys are lucky that I cut out the part on SRIS, because this is just the start. Man, I can give you some nightmares about that later if you want. So, in the beginning of this talk, in the title, I alluded to something called the AGI fire alarm. So this is based on a really, really great essay by Eliezer Yudkowsky, which I highly recommend reading. I could have just linked this as the talk, and it would have been better than anything I ever put together, but oh well. So the essay talks about one of the reasons that AGI is probably going to be really hard to coordinate on and really hard to get right, and it builds on a famous and pretty definitely for psychology standards robust and replicable study. So I'm now going to use one of the modern day's most expressive mediums to explain this experiment to you: shitty stock images. So the experiment worked the following way. So we had our great scientists. I assume they look like this. This is the first thing that came up with scientists, so this is probably how scientists look. They took small groups of students, I think groups of 3 if I remember correctly, and they put them into a room to take a test, like fill out some questionnaire or IQ, I don't remember, they just had to fill something out. And while this was happening, smoke started coming through under the door. They started to put in smoke, and more and more and more and more. And the experiment was to determine when would the students get so stressed out that they actually said something. When would they get up? When would they do something? So there's several variants of this experiment, of course. But so here's the punchline. The punchline is, of course, that, for many of the students, it was literally to the point that they were coughing on the smoke, and they still wouldn't say anything if the other people didn't say anything. So many of the results of the study had this one really stressed out student looking around to the other people who were all actors and were acting, to not respond to the obviously present fire. And I think it was 10% of people actually stood up and said something. So what does this tell us about humans? A lot of great things. So the question is, what does a fire alarm actually do? The obvious answer would be it alerts you of fires. Yes, and that is definitely partially true. It's definitely partially true that, if you get woken up in the middle of the night by your fire alarm because there was a fire, that's a good thing. It's a good service. But Eliezer and other people make a pretty good point that is maybe not the primary purpose of a fire alarm at all. A fire alarm is not there just to alert you, but it creates an socially acceptable common knowledge that there is a fire. When we hear a fire alarm, it means that I know that you know that there's a fire, and you know that I know that you know that there's a fire, that we all know that there is a fire, and now it is socially acceptable to panic. This is a sad state of affair, but this is very, very common among humans. Is that if you look into how humans actually behave, you see that humans care immensely about social status. They care immensely about what other people think about them all the time. This is a huge part of what human cognition is all about. And now, don't get me wrong, I love humans. Some of my best friends are humans. But humans tend to perform very poorly on certain kinds of threats, especially socially abnormal, vague, and exponentially growing threats. And we have had a wonderful, example of this just recently. I don't know if you guys heard about this, but there's this pandemic thing going on. I just recently heard about it. I never leave my house. And the fascinating thing about COVID was how utterly predictable it was. How absolutely mind-bogglingly predictable this was. We had all the information necessary to know exactly what was going to happen in January. Like China shutting down Wuhan? Are you kidding me? That is, how could you be more explicit? And this is something that our best epidemiologists, our best scientists have been telling us for decades is going to happen sooner or later. It was just a matter of time. And even better than that, we had a warning shot. Yeah. Anyone remember SARS in the early 2000s? It broke out in Southeast Asia. And I don't know if people know this, but the actual name for COVID is SARS-CoV-2, because SARS-1 was so great they had to make a SARS-2. Well, no, it was a joke, obviously. But it is a very closely related virus. In the SARS epidemic, when it broke out, people thought, okay, oh fuck, this is it. This is it. This is, it was a terribly deadly virus, very, very scary. And it was honestly a goddamn miracle that nothing much worse happened. It turned out the virus just was not that infectious. But this is basically the reason why countries like South Korea and to a degree China handled the situation so much better than the large country that shall not be named, is because they had a warning shot and they took it seriously. They had a very close call there. And, there were other close calls like swine flu and MERS and several others. I genuinely think that people in the future are going to look back in history books to the early 21st century. It's how the hell could these idiots not see this coming? This was so blatantly obvious, but we didn't do anything. And don't get me wrong, I'm guilty of this too. I didn't start panicking until mid-February. And I was early, all things considered. And I took a lot of shit for that. Literally people insulted and attacked me when I started to panic in mid-February. Well, why? And why was this when did these people start to panic? Well, when the fire alarm started. And the fire alarm in this case was, the governments and the World Health Organization, all these other lumbering behemoth, Kafkaesque behemoths finally getting into action and warning people. Then there was this social common knowledge that now it is okay to panic. Now it is acceptable. And of course, this was way too late. There are only two types of times you can react to an exponential process. Too early or too late. There is nothing in between. Human brains are not good with handling exponentials. It's just not something we do well. And if you don't want to be caught in an exponential, you have to react what feels like early, but is actually the only right time to react. The only right time to react to COVID was back in January. If you reacted past January, you have to reconfigure how your brain deals with exponentials. And I've already made the point, I think, that that AI is an obvious exponential. It's a self-feeding process. AI feeds on AI, feeds on AI. Also, of course, AI feeds on hardware development, which is a very famous exponential curve in the form of Moore's law. So what I'm saying is GPT-3 is SARS. SARS-1, not SARS-2. Okay, I swear I'm not a crazy conspiracy person. Allow me to explain. I want to make the case now that GPT-3 is our warning shot. This is the last time we have to start panicking before it's too late. I think that this is the time we have to start taking this problem very seriously and think very seriously about what are these AIs doing, what's going to happen with them, how do we control them, how do we align them. I think this is our last warning shot. And allow me to make a little bit to make the case of why I think this is the case. Okay, GPT-3 is a big deal. Well, okay. So for those out of the loop who've been living under a rock for the last, 6 months or whatever, what is GPT-3? Well, it's pretty simple. GPT-3 is an unsupervised autoregressive language prediction model, i.e. a glorified autocomplete. It is an AI model that is trained to predict text. So you give it some input text and it tries to predict the next word. So I might enter, hello, my name is, and then it might autocomplete, hello, my name is John, nice to meet you, or something like that. So GPT-3 is that's just what it means. It predicts text. It is, of course, the sequel to GPT-2, which, of course, is the sequel to the smash hit GPT-1. I'm just kidding. No one talks about GPT-1. I don't really know why, but no one talks about it. And GPT-2 was a very similar idea. It's basically the same idea. It was a text prediction model. It writes text from some kind of prompted input. But GPT-2 had a lot of problems. It was really cool at the time. Don't get me wrong. At the time, it was really, really cool. Believe me, I was involved. I know how that was. It did a lot of really cool things. It made a lot of press hype. It was pretty cool, but had some problems. There were some really obvious glaring problems with GPT-2. If you prompted it with a certain name, it would forget that name after 2 sentences and just start introducing new names. It was really hard to actually get it to focus on the parts you wanted to focus on. Sometimes it would just, collapse into repeating itself or doing some weird things like that. So people were like, it's kind of cool. But, GPT-2, even at the time of its release, was old technology. It came out 2019 and it used neural network architecture from 2017, which in the machine learning world is basically the Stone Ages. Yeah, so GPT-2 was a very dumb model with a very dumb architecture, trained on a very dumb task using very, just it's the most obvious way you would do this. There was no offense to the people involved at OpenAI who made this brilliant work. I know how hard this is now, but from a novelty, like a breakthrough science perspective, it was as dumb and as simple as it gets. So then came GPT-3, and GPT-3 has much fewer problems. Now, this is a point, one of the things I kind of cut, because I could have spent half an hour just absolutely going off the rails of how GPT-3 solves all these problems that were supposed to be so impossible to solve, and just casually does that, and no one's talking about it. So I'm not going to get into the technical weeds here, but for those that are technical, I would like you to know that GPT-3 did not complete an entire epoch on its data. It saw most of its data only once, which is a big deal because most AI systems have to see their data 100 times until they can learn anything from it. It can do tons and tons of different tasks with zero-shot, one-shot learning, and it does not have catastrophic forgetting. So it used to be a big problem that if you have an AI and you trained it to recognize dogs, and then you stop training it on dogs and you instead start showing it cats, it would forget all about dogs almost immediately. This does not happen. GPT-3 can, write, chat. It can chat. It can write stories. It can write blog posts. It can write philosophy papers. It can write. It can write code. It can write. It can do all these kinds of things. It's really hard to explain how big of a deal GPT-3 is unless you've kind of lived it, unless you actually use the thing and spent some time with it. And you always have to remember that humans have an incredible ability to take something absolutely phenomenally fascinating and make it boring. People just holy shit, people, I have a thing in my hand that I could telepathically communicate with anyone on the planet instantly and just download all the shit to say that, but I don't think people realize what a big fucking deal that is. Like, this is amazing. This is unbelievable. And we just, we just think it's boring. We just think phones are boring. And it's an incredible adaptability that humans have, truly marvelous. So I'm trying to counteract it a little bit by freaking out a little bit about how big of a deal GPT-3 is. So GPT-3 solved all these kinds of problems. It did all of these really fascinating things. Like, here's a fun example. Me and my friend Seb, who's also in the call, we have been working on a GPT-powered video game for quite a while now. And we used to use GPT-2 for stuff like generating texts for NPCs and their names and stuff like that. And we used to have to do like really funky things to get it to work. If we wanted it to generate names, we had to like write some complicated prompt like, oh, in this scene there is this character, this one, and ... And then sometimes maybe if the model felt like it, it would spit out a name we could use. But GPT-3 is not like that. What shocks me the most about GPT-3 is how we could just talk to it. You could just say, hey, GPT-3, this is a scene, this is a video game about this topic, and it has this mood. These are the characters. And it'll just give you characters. It's amazing. Or you could just, we also have like this technique where we're trying to figure out, we want to associate text with different emotions so we can like change how the levels look. And so we had all these like different heuristics and like, word associations or whatever. And now we just ask GPT-3, hey, GPT-3, what emotions are associated with this text? And it just works. It's mind-blowing. It just works. And no one's talking about this, is that you could just prompt it just with natural language. You could just tell it, here is a code sample that does, X, Y, Z. And it'll just spit out code. Of course, it won't work every time. Of course, there are a lot of problems with it. It's not perfect. Of course it's not. That's not the point. The point is that this works at all. That this works even 1 in 10 times is mind-blowing. This is a huge deal. So you probably think, well, okay, GPT-3 is such a huge deal. Well, it must be this massive revolutionary architecture. They must have had, the 300 IQ super brains working on this to develop, the next breakthrough AI algorithm or whatever. No. It's just GPT-2. Just literally the same thing. Same old dumb architecture for 2017. Same old training regime. Same everything. They just made it 100 times bigger. They just gave it more memory. They just gave it more GPU juice. They just put more computers on it and just let it rip. And it just did all this. Right. This is kind of a big deal. This is kind of a really big deal. And I don't think people are realizing how big of a deal this is. So there's long been this thing called the scaling hypothesis. So the scaling hypothesis, as the name may implies, hypothesizes that our current methods, we don't need better new revolutionary methods to reach AGI. Our current methods are enough if we just scale them up. As you might imagine, this sounds kind of preposterous because our methods are really just really big multiplications. It's really not that fancy. But as far as I'm concerned, GPT-3 basically confirms the scaling hypothesis. Well, you might say, well, it confirms it for this one architecture on this one, very restricted domain of just text. Oh, wait, no, it doesn't, because it also works on images. It also works on sound. It also works in reinforcement learning environments. It works on everything. Same architecture, just throw more computer in it, it just works. All right, okay. I think you can maybe see why I'm a little bit emotionally invested at this point. This seems like a really big deal. This seems really damn important. Because this means that there is no magic barrier. There is no, 20 years of research to find some genius algorithm left needed to get to AGI. This, if we take it just at face value, I mean, something like that could still be true. And we don't understand intelligence. Maybe all of this, next week will just stop and just be like, oh, well, this was the limit and it doesn't go any farther. Maybe. But like Scott Alexander likes to put in his essays, we should believe in the God of straight lines. As far as I can tell, we see a straight line that we put in more computer powers and the thing gets more intelligent on every single metric we can possibly think of. So as far as I'm concerned, I'm a worshiper of the God of straight lines, and we should take as our null hypothesis that this is going to continue. And do not get me started on hop-field networks. Oh boy, that's a whole nother topic. So you might say, well, surely just a simple world model is not harmful. I, by the way, now only noticed that I haven't introduced the word world model. all it means is a predictive model. So GPT is a world model of text. Its world, quote unquote, is made out of text, and it just learns to predict that. We could have a world model on images or video or anything. It just tries to simulate the world around it. So you might say, well, okay, maybe this is true. Maybe this is true for these like world models, but that doesn't seem like that big of a deal. So okay, maybe some people can generate some better text or whatever, or better images or whatever. But it's not something to like take over the world or something like that. Well, first of all, no, that is definitely something that can happen. I really recommend reading this essay that is linked in the notes, which is by the one and only Gwern. If you've never read a Gwern essay, you are in for a treat. And the second point I want to make is, even if this is not the case, it can be used to amplify a different agent. So let me quickly try to explain what I mean by this. So for those that don't know, reinforcement learning is one of the simplest kinds of learning. It is like Pavlovian kind of conditioning, pleasure pain kind of things. It's like, you eat food, that's good, so you want more food. And pain is bad, so you try to avoid pain. That's kind of what a reinforcement learning agent does. It tries to get a high positive reward and avoid negative reward. And these things are really hard to train. They are very finicky. We can do it pretty reliably for like small tasks, like playing an Atari game or whatever. But for really complicated tasks, this has been very hard. You can ask DeepMind about it. I think you'll give David Silver PTSD if you ask him about StarCraft. So imagine the following scenario. I am a small brain, weak, little, dumb reinforcement learning agent, because it's really hard to make a smart reinforcement learning agent. So I don't understand how the world really works. I know I want reward, but I don't really know how to get it. I don't really understand how the world works. It's all really complicated. It's all really confusing. So, and I am presented with the following scenario. I can go left or I can go right. The problem is, because I'm such a weak agent, I don't actually know whether left or right is the right choice for me. I don't know, where I'm going to get reward. So in the default scenario of reinforcement learning, I'd be pretty much screwed. There's nothing I can do because I just don't understand the problem. I'm not smart enough to understand the problem. But let's imagine I have access to a GPT that is, trained on this environment. So it predicts how this environment works. And so I can then simply ask it, well, GPT, I go down the left path, ... And GPT replies, you go down the left path and you die and get no reward. And then I say, well, GPT, I go down the right path. And GPT says, you go down the right path and live and get a bunch of reward. So I go down the right path. Did you see what just happened there? I made myself into a stronger, more intelligent agent without actually learning anything myself. I bootstrapped, I amplified my own intelligence to become a more powerful and potentially more dangerous agent by using this completely unsupervised, completely non-intelligent, quote unquote, prediction model. GPT in this scenario, this GPT X or whatever, was never trained to predict the kinds of things that I'm interested in. It was never its goal was never to find reward, to do anything like that. But I could leverage what it has learned about the world in order to make better decisions, to become more intelligent. And we can talk about this a bit later if you're interested, but I am very, very sure that this is basically what's happening in the human brain between the neocortex and the basal ganglia. Is that the neocortex, the big wrinkly part of our brain, seems to be an unsupervised world model that is deeply integrated with the basal ganglia, the striatum, nucleus accumbens, and a few other bits and pieces, which are the parts that actually determine what actions we take. This sounds like a crazy conspiracy theory, but it's actually pretty standard systems neuroscience. We can talk about this later if you're interested. So, with what we've learned so far, I want to make the case that I can now show you how to make AGI in 3 easy steps. Come on, kids, it's going to be great. Disclaimer, it is not actually great. Do not do this, because it will 100% end in complete catastrophe and the end of the world as we know it. So, assuming you have, a Jupiter-sized computer laying around in your backyard, as one does, I'm pretty confident that I know how to build an AGI that can fulfill your wildest dreams, whatever those dreams may be. Step number 1, build an enormous world model. Just put everything into there, every sensor, every piece of data, all the computing power and memory, everything. If I just stuff it in there, stuff it all in there, make it simulate the world as best as it can. Just stuff everything into there. Just make it as big as possible, no limits. Step number 2, build a reward model from your preferences. What this means is you take a reasonably sized neural network model, and you show it a bunch of things you like and things you don't like. And then you try to teach the model to predict what things you will like and what things you won't like. This is where things go horribly, terribly, apocalyptically wrong for many reasons. I'm not going to elaborate on it too much there, but I hope it's somewhat obvious. If not, read the attached papers, or I can elaborate on that afterwards. So the reason you need to do this is you have to train the model, on what to do, and your puny human ape brain is so slow that it can't actually judge things fast enough to be able to be a good training signal. And also, maybe the things that it has to judge are super complicated that you can't handle. So that's why you need something like this. Step number 3. Build a reinforcement learning model with access to your world model for amplification and train on the reward signal from your reward model. And there you go. Instead of world-ending paperclipification, you did it. You destroyed the world, because this is definitely going wrong for many, many reasons. Because you did not do your homework on AI alignment, and you just let go, a genie on the world out of control. So I do have some hypotheses. I do have some theories about why this in particular works and why it works so well. We can talk about that later. It's not too important. What's important is well, okay, first of all, credit where credit is due. These ideas are based loosely on the idea of iterated amplification by Paul Cristiano and others. Also, disclaimer, iterated amplification is a much more refined proposal for how to build good AI that is also aligned with us. This is not actually how iterated amplification works, but I personally actually have very large problems with iterated amplification, and think that iterated amplification is a very bad direction for how to make safe AI, but that's a whole nother topic. So, all right. This is a whirlwind tour. Let's try to recap what we've been talking about so far. My first claim was AI is potentially the most important thing to ever happen. Intelligence solves our problems. This gives exponentially more intelligence. It allows us to do exponentially better things. Second, that intelligence is not guaranteed to be on our side. It's not guaranteed to do a good thing at all. There are very, very hard, very complicated technical and philosophical problems that need to be solved to ensure that the AI actually does good things. Number 3, GPT-3 is the closest to a fire alarm we're going to get until it's too late to react. Until things are already so out of control and going so quickly, it's already too late to do anything about it. So that's kind of bleak, partially, at least. The question is, well, what do we do? I don't know, lol. Okay, I can maybe give you a better answer than that. I like to say that AI, I forget who I first heard this from, I apologize, but AI alignment is philosophy with a deadline. There are very, very hard questions, not just in philosophy, it's also science and engineering with a deadline. There are very hard, very technical, philosophical, engineering, and scientific problems that need to be addressed, in my opinion, before very strong AGI is deployed. Well before, hopefully. And this is important. This is very, very, very important. If I can like, take a step out of the goofy character for a moment here and be a little serious. This is very important. I genuinely believe that we live in an unusually important time in history. I think that we are on the precipice. We're on the precipice with an endless abyss below us, an endless, never-ending dark abyss of extinction or worse. Well, above us are the stars of an actual paradise. I think this deserves to be stressed, to be repeated, to really understand that if this works, if AI works, if we can make exponentially smart AI that solves our problems, we have a chance of being okay. We have a chance of fixing everything. We can fix every disease, every kind of suffering, every injustice, every war, famine, crime. Everything is a technical problem that can be solved with enough intelligence, with enough resources. The stakes are literally astronomical. We don't know if other intelligent life exists in the universe or not. It may well not. And if it doesn't, in many ways, whether or not we get off this planet, whether or not we weather this transition could decide the fate of the observable or the reachable universe of our galaxy. If we go extinct, if we lose, we lose. Nature is allowed to kill us. There's no second chances. There's no heaven, there is no hell, except the ones that we built. There are no second chances, there's no second life. If we fuck this up, that's it. Game over. AGI is like climate change, but even worse. It has even harder problems, even shorter deadlines, and even worse consequences for failure. And you know, that's scary. That's really, really scary. And if this doesn't scare you, if you're trying to be so like detached from that you do not feel visceral, emotional scared from how of this yawning abyss below us, I think you're miscalibrated. I think that you are underfeeling this. You're not giving this enough feeling as it should, as a good, rational person should. I might be wrong. Don't get me wrong. I might be insane. Always keep the back of their mind the possibility that I'm insane. That is always a possibility. I know that throughout history, every culture has believed that they lived in the most important time in the world and everything hangs in the balance. Everyone believed this. And I've tried to correct for that bias. I've tried to, look at this from every possible view, angle, everything possible. And I just can't shake it. I just can't find any interpretation that makes sense to me any other way. It just seems so obvious that if you just look at the straight lines, just draw the straight lines, that this is where it happens. This is what matters. So now what? I could give you a bullshit answer about what you can do, but I don't want to do that. I could give you some answer like, well, if we just all work together in a partnership for democracy and human rights, everything will turn out fine. I could tell you a story like that. I could tell you some story about, all you have to do is, do your part. I'm doing my part. Are you doing your part? I could tell you all kinds of stories like that. There are many stories like that. I could tell you a story about how if you just go over there and you do this thing I tell you for the motherland, everything's going to turn out fine. But those stories are bullshit. They're just not true. There is no simple way to solve this. These problems are hard. They are fundamentally, irreducibly hard. No one knows what to do, and no one is in control. This is really important. The way our human ape brains work, we have this like with a fire alarm, we have this incredible importance and status in who's on top, who's in charge, who makes the decision, who has authority. This is incredibly fundamental to how we humans perceive the world. But the truth is, that's just not how the world works. The world just doesn't care about your authority. One of the things that attracts people to conspiracy theories is that they want someone to be in control. Even if it's some evil satanic cabal or whatever, that's still better than the alternative, that no one is in control and the entire world is just meaningless chaos. The truth is, that's how the world is. And we have to face that. We have to say that there is no, I can't tell you what to do. I can't tell you how to solve this. If I could, I would. If anyone could, they would. But this is a fundamentally hard problem. This is something that people just have to work on. Many people who know me for extended periods of time consider me, on the one hand, one of the most depressed, nihilistic people they've ever met, because I believe that we are just heading straight for just this terrible, irrecoverable apocalypse that will destroy everything we've ever cared about forever, or worse. But I'm also, in many ways, one of the most hopeful people, because I genuinely, really, not just for some religious reasons or whatever, but just from looking at the fact, just completely rationally, optimistically, I think we can do it. I think these are problems that can be solved. If you would have asked me this like 1 or 2 years ago, I would have probably answered differently. But I have truly been shocked how much progress has been made just over the last 2 years. Things that I didn't even know where to start, that I feared might be unsolvable, aren't solved. But progress has been made, visible, actual progress. And of course, if you read the cutting edge in AI alignment research and whatever, there are way more questions than we have answers. But there is progress. There's this tangible feeling of progress. And that gives me more hope than anything else in the world. And this is on the backs of extremely motivated, extremely intelligent, hardworking people that said they want to make a difference. They want to save the world. If I can get on my high horse here for a moment, if I wasn't already, I think our culture has a very fundamental problem. Is that in our culture, it is not acceptable for someone to stand up and say, I'm going to save the world. And don't get me wrong, I understand why this is the case. I understand signaling equilibria, virtue signaling. I understand status hierarchies. I understand. But this seems like a problem. Eliezer wrote a great essay called Hero Licensing, which I recommend reading, where he talks about this. And that if you try to save the world, if you say I'm going to go work for a corporation and make $60,000 a year, people will pat you on the back and say, good for you, buddy. But if you say I'm going to save the world from AI taking over and destroying everything of value and save the long-term future of our galaxy, that's not something you're allowed to do. That is a socially unacceptable thing to do. That's something that children do. It's something that teenagers do. I bet some of you are cringing like hell for the last 5 or 10 minutes that I've been talking about this kind of stuff. I bet you think I'm an idiot, and I can't blame you. I don't blame you if you think that. But the truth of the matter is the world needs heroes more than ever. Not ordinary people that can take orders and do some kind of menial task repetitively. This is something that needs heroes. People that stand up and without shame say, I'm going to save the world. However I can do it. Because the truth is, the reason I can't tell you what to do is not only that I don't know the answer, it's also because I don't know you. I don't know who you are. I don't know what you've accomplished. I don't know what you're capable of. I don't know if you're capable of making a difference. I don't know if I'm capable of making a difference. I very seriously considered not giving this talk for the simple reason is that I don't know if this was a good thing. Did this make the world a better place? Or did this make things worse? Maybe I inspired some of you to use this bad way of making AGI and it will destroy the world. I don't know. And I have to live with that. I could be boisterous and arrogant and say, oh, I know I'm doing the right thing. I'm so sure of myself. But that's just not true. Because I don't know if I'm right. I don't know if I'm a good person. I don't know. I don't know what the right thing is to do. And it's important to keep that humbleness while still working, while not giving up. We need heroes that are willing to stand up and do whatever they can in their own capacities, that they have to realistically assess what you can do, what you can't do, and really try. Because honestly, I am shocked how many low-hanging fruit there are. How much, the AI alignment world is teeny. Compared to large established academic institutions, it's minuscule. It is so few people with so little resources, and they have made such amazing breakthrough. I used to read Nature magazine every week. It is it's the premier publication for high-class research. I stopped reading it because it was boring. And the stuff that these AI alignment people were doing, every month was way more important, in my opinion, and way more interesting, way more novel, way more breakthrough, and actually something that changes the world. This is not respective of all Nature papers. Of course, I shouldn't have to preface that, but you know what I mean. People believe that heroes are born with a hero license, that there is some kind of immaterial aura around them that shows that they are the protagonist, that they are allowed to save the world. And I think this is the wrong way. This is a fundamentally flawed way to look at the situation and any situation like this. I got into this field by tooth and nail. No one taught me. I didn't have a teacher. I didn't have a mentor. I wasn't told to do this. I did it because I thought it was the right thing to do and because it was pretty interesting. That's also a factor, of course. And I'm not saying that I'm doing the right thing or that I know or everything that I did was the right thing. I don't know if what I'm going to do in the end of the thing is going to be positive, negative, or most likely just not make a difference at all either way. But I think it's important to try because I think that some of these people that have tried have made a difference, and maybe you can be the next one to make a difference. You need to take initiative. That is what I'm trying to say. I'm trying to tell you that no one's going to lead you by the hand how to save the world. Being a hero is about being independent. It's about you putting on your boots and just walking and just don't stop walking until you get where you want to go. You have to do things you don't like. You're gonna have to, do horrible things like learn math. I know. It's terrifying. In these links, I have a few links of people that do try to help you along, that do try to give resources in fields like this to get you into this. But you can't rely on that. There are also busy people. None of them are going to take you by the hand. You need initiative. You need to take responsibility. That you have to say to yourself, I want to make the world a better place. I want paradise. I want to engineer paradise. I want to do whatever it is I can to make it happen. If you take one thing from this talk, I want it to be that I want more smart people to try more things. I feel there is a terrible arbitrage happening where there are so many incredibly intelligent people working in completely dead-end and useless things. There are some fields that are just so much higher leverage. They're just so much more important and so under-researched, underfunded, underappreciated that a single researcher in this field could do 100 times more than a researcher in another field. And if you believe me, or you don't think I'm utterly fucking insane, I believe AI research and safety research is the premier field for this. So, in summary, what I'd like to say is, I don't know how to save the world, but damn it, I'm going to try. Thank you.
Thank you, Connor. And now we'll start up some questions and answers. There are a lot of questions today. It's wonderful. So I'll read those off. And Mr. R asks, how elastic are the returns in investing in an AI fire alarm at the moment? How much effort will we need to put in to keep a fire alarm going for 5, 10, 50, or 100 years? Where would we have the greatest leverage?
Okay, so very complicated. I guess this depends on what you mean by a fire alarm in a sense. So the fire alarm in the original metaphor is this idea of some kind of social system. I can also stop presenting now, actually. Is some kind of social system that makes it common knowledge that it's now okay to panic about something. And so first of all, I am not sure that such a thing could be realistically created, at least in the current way that humans and their psychology works. By the way, correct me if I'm misunderstanding what you meant by a fire alarm. So I'm not sure if this is the right way to go it. So this is kind of like what's called, I think, Price's Law or something like that, is this idea of how much does a median person added to the work actually contribute. So like Price's Law is the idea that almost all of science happens by like the top 1% of scientists. Whether or not this is true is controversial for obvious reasons. But yeah, it's like the question. This is why I said I don't know what you should do, because I don't know you. I know what you're capable of. Maybe you're a 200 IQ genius mathematician, in which case you should probably send MIRI an email right now. But, maybe you have some other talents that you could do, or maybe you don't. Because, I don't want to treat you like children. Maybe some of you cannot do anything. Maybe there's literally nothing you could do. Maybe there's nothing I can do. Maybe I'm not talented enough to make a difference. I don't know. And so in that regard, I think that would it be very useful if every politician in the world started talking about AGI alignment? I don't know. I'm very uncertain about this. I don't know if this is a good idea. I wouldn't know how to accomplish it. So I know this is kind of a lame answer, but I will have to defer to uncertainty in this regard. It seems like there are lower hanging fruits, depending on your skills and your resources, that could result in higher leverage than that. Depending on if you're really good at math, talk to MIRI, Machine Intelligence Research Institute, intelligence.org. Talk to them. They're like the premier people for that. If you're a really good machine learning engineer, consider working for OpenAI. Consider working for DeepMind or someone else with good safety teams. Or maybe even just donate money to the Open Philanthropy Fund or to MIRI or someone like that. Those are probably the like 0th order suggestions I can give you, but my primary suggestion is dig into the field, make your own opinions, read the papers, read 80,000 hours, figure out what your comparative advantage is. That's your highest leverage.
Alec Morgan asks, do you see wireheading as a pervasive failure mode? Is there any
Yes.
reward or loss function that isn't subject to it? Is there a way to
Yes.
mitigate it, perhaps with cryptography?
Funnily enough, yes, yes, yes. Yes to all those answers. So I actually just very recently found out about this. There is actually, I'm sorry, let me try to actually find the paper. Damn it. There is a wonderful paper that I have not yet fully read. Is this? No, this is not it. Yeah, this one. I'll post it in the chat. So this is, this also the embedded agency sequence is a really good one to read. It's in my presentation notes, which, by the way, I should share. Sorry. These are also my slides, so you can see all of the references.
Okay, we'll also share that afterwards. Yeah.
Yeah, okay, yeah. So wireheading, I think, is one of the most fundamental failure modes of reinforcement learning, is that by default, I don't see any possible way whatsoever to avoid wireheading until this paper came to my attention, which seems to show that if the reward function is a part of the evaluation algorithm, you can like provably show that wireheading will not occur. I actually haven't fully understood the paper yet. MIRI papers take me a while to read, so take this as a weak endorsement of what this paper says, but it seems very interesting, seems very, very promising. Of course, the problem is that this does not apply to all kinds of systems, particularly to humans, is that wireheading is definitely a thing among humans. I don't know if you've heard of these things called drugs. They're pretty cool. And wireheading is... it's like one of my main problems that I kind of cut from the talk. I had like a whole, I had like 3 slides on this, is that I think one of the most common failure modes that I expect to happen is that we're going to have an AI that's very, very good at optimizing. And then we're going to tell it what we want. And then it's going to optimize that. And it's going to be great. And it's going to optimize it even more. And it's going to be even better. And it's going to optimize it even more. And suddenly things go completely out of control and things go completely crazy. And the AI is doing, bending the laws in physics, to do something bizarre that somehow, for some reason, triggers something in our brains, reward functions, somehow something to do that thing. So like optimizers tend to find these edge cases. There's a really great paper by OpenAI, which is also in my notes somewhere. It's also at the top of the OpenAI blog right now, if you look at it, where they trained a reinforcement learning model to create summarization of text using a reward model. And the fascinating thing is they actually systematically tested this. They showed that if you have a reward model that is similarly strong to the generation model, it produces really good outputs. And this also had something to do with like KL regularization, technical details, doesn't matter. And they showed if they remove these limits on the summarization network, the stronger the summarization network got, the worse the results became. Because it found weird edge cases that break the reward model. It would find like one word that, if repeated over and over again, would trick the model into giving it millions and millions of reward, basically. I think this is my main problem with iterated amplification. So the stuff that Cristiano did do this work. So like Cristiano is aware of this. I'm not like dunking on, oh, I am so much smarter than Paul Cristiano. No, they know this. They are researching this. This is a fundamental problem that needs addressing. And there is this method, which is really interesting. So for these, like for the technical people, you might want to look at this. This is pretty interesting, where you could build AIs in certain ways that should avoid them to wirehead themselves. I'm not 100% sure if it applies in every realistic scenario, because again, it takes a lot of like mathematical, abstractions. It's not an actual physical agent or anything, which makes everything much more difficult. So I would say incredibly important problem. Probably the thing I'm most worried about AI alignment, probably period. Needs more work. Yeah, God help us.
Okay. Well, Benny Felkovich asks, is it possible that methods for deprivation of hardware resources are a more practical path to prevent AGI catastrophe, or at least buy some time for AI alignment?
Yes, and also not really. Well, so I do think that compute is the new oil. I think that compute is the limiting resource currently in our capabilities of building very strong AI systems. I think that. So this is also like one of the things I've learned doing Eleuther. One of the reasons I did this dereplication project wasn't really because of the model per se. I didn't really care that much about it. It was cool, but it was like I was more worried about. I wanted to figure out how hard is this really? Like, how hard is this actually to build? How much does hardware matter? How much does programming matter? How much does science matter? Et cetera, et cetera. And my current conclusion is that compute is what matters. It used to be data was very hard, but I think as our algorithms become more and more, in general, better and better with handling noisy data, and there's also just more and more large data sets accessible. Like, people say, oh, it must be so hard to collect terabytes of data. Just turn on a full HD camera for a few hours. If we're training on real world, there is no dearth of data. We have plenty of data. That is not a problem. The problem is the compute to crunch it. And, I could talk about my hardware conspiracies for ages. But I mean, in many ways, like there is a optimistic interpretation of this, that in some ways we could say that we got lucky. That honestly, the fact that AI seems to be bound to hardware might be the lucky case, because hardware, unlike algorithmic progress, is pretty predictable. Moore's law, every 2.5 years or whatever, transistor counts roughly doubles. I know this is not exactly true, but it's also not exactly false. So like I feel that the death of Moore's law has been greatly exaggerated. It feels like it doesn't seem to be slowing down to me, and all industry experts I kind of talk to kind of say the same, that yes, we have to do some really complicated things, but that's always been like that. Like people have been saying Moore's law is going to die since the 60s. It doesn't seem obvious to me that this time is going to be different. It might be, but it's not obvious to me. And it's really important, I think, so here's my prediction. I predict, very unfortunately, that sometime in the near future, governments are going to start classifying large amounts of hardware as weapons technology. I expect that governments are going to start treating large amounts of GPUs the way they treat uranium ore. And so I used to hate the comparison of AI to the Manhattan Project because it doesn't seem correct. Because, nukes are just destructive. Well, AI, is not just destructive. It can be destructive, but it can also be the exact opposite of destructive. So it seemed always like a pretty poor comparison to me. I have partially changed my opinion about this. So there is a really great blog you can Google called Nuclear Secrecy. It's a really good blog, and they have I don't have the link on here right now, unfortunately, that is about the Smythe report. So the Smythe report, or Smith, I don't know, whatever, this thing, the Smythe report, which is the report that was released after the Manhattan Project to the declassified parts of the Manhattan Project, basically. And they made a great point that I think is really important. We all think that the Manhattan Project was this great triumph of nuclear science. And we have these 300 IQ super geniuses solving these super technical nuclear physics problems to single-handedly build the bomb. But here's the thing: we think that because that's what was in the Smythe report. But what was in the Smythe report is what was declassified. That's the least important thing. That was the thing the military thought was dispensable. That's the thing they thought was not important. What was way more interesting of the Smythe report is what was not in the report. What was not in the report, what the military thought was the actually hard things to do, is the most boring things imaginable. It was how to build really big buildings. Like the factory at Hanford, I think, was like the largest concrete building ever constructed at that time. A large concrete factory. Or how to stop the uranium hexafluoride from eating through pipes and stuff like that. That's what they cut from the report. The nuclear bomb wasn't built by a nuclear physicist. It was built by DuPont engineers doing totally normal, boring metallurgy and engineering and chemistry. They're the ones that actually built the bomb. There's also a quote, which is somewhere in the blog post about it, where they where someone, I forgot who said it, but he said it basically is that if you want to build a nuclear bomb, you're going to have to turn the entire country into a factory. And that's what General Groves, the general in charge, did. They built this huge factory complex. By the way, if any of you have not read The Making of the Atomic Bomb, the book, fantastic. You have to read it. Must read. Fantastic book. One of the best history books ever written. And it will give you a whole different perspective of how these kind of things work. So the Manhattan Project was like 1% science. You had like this one teeny percent of people. Yeah, someone had to figure out fission. Leo Szilard had to come up with these things or whatever. There was that part. But 99% of building the bomb was building the bomb, building really big machines and big power plants and really big pipes. That's the hard part. And funnily enough, with Eleuther working on GPT-3, I've come to the conclusion that that is also the hard part about GPT-3. The science is super easy. As I say, this is an ancient model from like 2017. This is not complicated. You don't need to be a Berkeley professor to figure this shit out. It's not that complicated. The complicated part is optimizing your latency, making sure your matrix units are fully filled, finding the stupid bug you have somewhere in your attention code. Just really boring engineering stuff. 99% of the stuff that we've done on this project is just really boring, routine engineering work. And compute. Those are the two things. And compute is the new uranium. It's the new oil. It is the new rare substance that you need to build these kinds of devices. So I do expect that in the future, it's probably going to be regulated in some degree, because I see this as the only possible policy angle to have any kind of control over this. And I mean, yeah, this is a long topic, and I'm not sure how I feel about many of these things. I don't know what I would recommend to policy holders or such in this degree, because there's no slowing down AGI. The price is too big. If the US says, okay, we're going to stop, we're not going to allow people to sell, GPUs anymore. Yeah, I'm sure the Department of Defense is going to stop buying GPUs. Yeah, for sure. Right. Like, no. Yeah, I want to believe, but I don't see how it's going to make a difference. Or, and even then, if the US bans, big computers, everyone's just going to move to some other country. You think Russia's going to stop doing this? You think China's going to stop doing this? Come on. I'm very cynical about political and social approaches to solving these problems, which is why I put so much faith in these hero hackers, as silly as it might be, trying to solve the technical problems, because these social problems just seem very, very hard and very slow.
Okay, Alec Morgan asked a question. I'll follow up with one by Jacob Fung. Has any research been done on whether or not value alignment is even a solvable problem? Is it possible that the only way to assure an AI stays approximately aligned with our values is to ensure that it barely, if at all, exceeds our intelligence? And then Jacob Fung extends on that, and he says, what things, or generally, did you think were unsolvable, but which were then solved?
Great questions. So there is work on value alignment not being possible. There is, in fact, a general theorem that shows that in the most general case, you can assign any utility function to any human if you give them a bad enough rationality, basically. Is that you have to define both the rationality and the utility function to be able to make strong statements about how an agent will actually act. So you could find any absurd utility function for humans and just say they're very bad at optimizing it. So I've also recently seen some other results that had similar things that claim in certain, mathematical models, there's these things where it can't be learned efficiently and lots of things. Honestly, I don't care too much about these results necessarily. I think they're interesting, and I think they're worth thinking about. I think the result about you can assign any arbitrary utility function to a human is one of those things that's obvious in retrospect, but at the time was actually pretty controversial, I think. So I was at least to me, it was eye-opening that was true. But in retrospect, it's actually pretty obvious. So I think that there is an argument to be made that, so I actually believe that this is partially true. I think that value alignment in at least one important way is impossible, in that I think the human utility function, whatever the humans use to approximate utility function, is underdefined, is not defined for all possible cases. I think that similar to these models, if you go off training distribution too far, you'll find some weird edge cases where the model just completely falls apart. And I think this is an unsolvable problem because it is just how our brain processes information. Is there is just some things it cannot do, and it just cannot handle, cannot work with. So this is why I am skeptical of iterated amplification. So iterated amplification, as I've mentioned, is one of these proposals where they basically have this idea is that you train a reward model, use that to train a slightly smarter agent, and then you use that agent to train slightly smarter agents, train slightly smarter agents. It's a bit more clever than that, but this takes us a little bit afield. And I am super skeptical of this. I do not think this will work for this exact reason, because I think that this might work, for n steps, but there's going to be some step where we're so far off training distribution that even if it perfectly modeled human preferences, it would just go crazy. So in many ways, I think that there is a limit. So one of the fundamental hard philosophical questions, because I think it's important, AI alignment is not just engineering and science. It's a lot of engineering and science, but it's also philosophy. That there are fundamental questions about philosophy, about utilitarian philosophy that have to be answered. So this gets into moral realism, moral anti-realism, and stuff like this. And without taking any sides here, it feels to me, given what I know about the universe, how it works, how these kinds of things work, that there are some universalizable characteristics that we would want. Like, I don't have a general theory of suffering. If you give me a black box and tell me, is this black box suffering? I can't answer that in the most general case. But there's a lot of cases in which I could. And I have this hope, this is one of the researches I would like to work on at some point, is trying to work on this idea of are there some kind of is it possible to define some kind of defensible, strict mathematical theory of suffering or of utility that has some kind of at least partially universalizable properties? And I'm somewhat hopeful for this, but I can't say that it is, a more than 30% kind of hopeful, which is, all things considered, probably pretty good. I hope that there are principles that can be distilled from human morality that are more general, that are stronger than the preferences humans actually follow. Because as humans, we do a lot of things that we actually disavow of. A lot of humans will do a thing, but then say, I wish I hadn't done that. I wish I was a better person, hadn't done that. So this is also sometimes called reflective equilibrium. It's this idea that if you have a philosopher, a brilliant philosopher, and you let him just think infinite time, does he eventually converge on something? Does he eventually converge on some perfect philosophy or not? It's unclear whether this is true, but I think it's not out of the question that something at least approximating this could be true. And if that is the case, that's what I would want to optimize. I would not want to optimize my reward function or your reward function, but some kind of reflective equilibrium, some kind of universalizable utility function between us. I mean, maybe we can make a deal with the AI to give us a few thousand years of, indulging in all our human sinful pleasures before we join the, the moral realist hive mind or whatever. I don't know. But again, if I was a better human, I probably wouldn't want that either. So it's a very hard question. Very smart people are thinking about this. I wish more smart people would think about this.
Duncan Fowler asks, how does your open source version of GPT-3, GPT-Neo, help with AI alignment?
Yeah, so this is one of the unfortunate sacrifices that were cut from the talk, because that's a pretty obvious thing I should have discussed. So thank you for bringing it up. I'm sorry it wasn't in the main talk. So this is a complicated issue, actually, and it has changed multiple times. So first of all, disclaimer, this project did not start with some kind of genius, 3 steps thinking ahead plan. It was just hey, guys, this seems pretty cool, huh? Want to do this? Yeah, that's how the project started. There wasn't much thought into it. It's like, hey guys, let's look at this thing. It seems kind of neat. We didn't expect to get very far. We got a lot farther than we expected to. By the way, I think I never posted the link to our Discord. Feel free to join us if you want. We're a pretty cool crew. And we got way farther than I ever expected us to get. Way, way farther. Yes, we are a Discord. And we got way, way, way farther than any of us ever expected us to get. And we got a lot of attention. We got it involved. I have been in conversation with, lots of people from like OpenAI, from Google, from other places and whatever. And different members of our teams have slightly different views about why this is a good thing or a bad thing. So I'm just kind of speaking for myself here. So for myself, I did this project mostly because when this first happened, I freaked the fuck out. I completely freaked out. I was like, oh, holy shit. Oh my God. The scaling hypothesis is true. My life is a lie. Everything's going to, AGI is going to happen tomorrow. Well, not literally, but, it kind of felt like that. So my first goal was just to sit down and try to figure out, okay, how big of a deal is this? Get hands-on engineering experiences. How big of a deal is this actually? Figure it out, not just hypothesize about it, but actually try to figure it out. Actually try to figure out how much it is. And I've learned so much from this project about the Discord link is in the Eleuther AI link. And it's so the reason besides all this engineering effort that we put into it, it also okay, so this is it's kind of a fishy argument. I would like to just preface as a bit of a fishy argument. I think it's fishy too. I'm not 100% sure how much I think this is true or not, or how much it matters. But in a way, it was a kind of this was going to happen either way. Like whether I do it or someone else does it, someone's going to do this, and kind of like it might as well be me. It's like this might sound a little self-aggrandizing. I'm sorry about that, but this is just an actual experience I had. Is that a year ago I did a thing about GPT-2. Long story, doesn't matter. But at some point I got talking to a researcher from MIRI about this, and he said something to me that kind of stuck in my head ever since, and it's kind of been messing with me. And he says, "What are the chances that it would be you of all people? What were the chances that someone interested in, alignment and like all these like topics and stuff would be the one to do this thing and not some troll off 4chan? It seems incredibly convenient. It seems really lucky that it was me of all people that happened to do this." And ever since, I felt kind of responsible in some way that like, I think I'm pretty aligned, all things considered, for a random dude on the internet. Like, I've seen much, much worse, let me put it that way. And so I try really hard to, like talks like this, to try to get this message to people, to try to communicate with people, and try to just expose them to these ideas that sometimes, again, because people don't want to stand up and say, I want to be a hero, but I'm trying to sell you, okay, I'm going to embarrass myself. I'm going to embarrass myself. I'm going to take social harm by getting up on my chair and screaming, we need to be heroes. We need to be better. We need to do better. We have to take these arguments seriously. And so in a way, with Eleuther, we've kind of corralled these bunch of feral hackers into this somewhat, at least, thinking about these more aligned things and such. But I'd like to also make the disclaimer here that I am still fully open to the possibility of not releasing. Like, if I see a very convincing argument that we should not release, I'm out. And I've told everyone in Eleuther this many times, is that I will drop everything if I become convinced by someone that that's the case. And I've had conversations with people from OpenAI and stuff like this that made pretty good points. Like, just 2 days ago, I talked to a counterterrorism expert who was been researching with GPT-3 and stuff. Really cool guy. And the fact is, I don't think GPT-3 is very dangerous. I'm very sorry to the people I've been talking to, but I am just continue to be unconvinced. I just don't care about it generating offensive racist content. Yeah, it sucks. Don't get me wrong, pretty shitty, but I don't care. It's like, I'm sorry. It's like, I just genuinely don't care. The fate of the universe is on the one hand. On the other hand, it's like, oh, it said something mean about black people. Like, don't get me wrong. That's a shitty thing. That should not happen. But it's just not in my top priorities. I want these things to stop. And if you want to read about this, I have written like, 30,000 words of blog posts about these issues and how I think these should be addressed. For me, this is kind of just like over. Like, I think that this technology is going to happen one way or the other. If OpenAI doesn't release it, if we don't release it, then Google or Microsoft or whatever it is, we can't keep it out of the hands of evil people anyways. Do you think, like Russian intelligence or Chinese intelligence can't build this if they want to? Of course they can. I mean, it's silly to imagine that, as long as the good guys, as long as the good guys have it. Okay, that is a very not nice thing to say, Graham Pash. I would like you to not put the words like that into my mouth, please. That is a very non-charitable interpretation of what I'm trying to say. So I will not be responding to that. If you want to say that in a friendlier way, I will be happy to talk to you. So, yeah. So the bad people already have this, as far as I'm concerned. The only people that are being harmed by not having public access to this are the low resources researchers type people. The people, actually, like, sure, maybe some low effort trolls will get access to it, and that is a non-negligible cost. I would like to say that I am uncertain about this. Is that if someone convinces me that I'm wrong, that I'm, if I am misjudging how dangerous these kinds of things are, I will change my mind. But so far, you can read my 30,000 word essays on this kind of stuff if you're really interested in that. But it seems like, well, first of all, also, it's not clear to me. It's not clear to me that we're going to succeed. We could still fail. It's still far from clear we're going to succeed. We've gotten very, very close, but it's still unclear. And second of all, we are, in my opinion, actually doing a pretty good job of addressing these things. We actually have a side project where we're trying to make our model radioactive. What that means is we introduce statistical biases into our model so that its output can be detected using using certain algorithms, much better than a vanilla model could be. We were also currently considering using legal methods. We are considering releasing our model as copyleft, meaning that anyone that uses our model has to disclose it and has to publish their version of the model, or else we could apply legal pressure. So it's not that we're not taking these things seriously. We are thinking about it. But I find that many of the conversations around the dangers of GPT-3 and what should be done are very low signal. I think that people are kind of talking past each other. It's like this isn't a dichotomy between, trolls use the model for QAnon conspiracies, or trolls don't use the model for QAnon conspiracy. If that was the dichotomy, of course I wouldn't want them to do that. But that's not what we're talking here. That's not how this thing works. It's just not how things, the IRA, the Internet Research Institute or whatever, if they want a GPT-3, they're going to make a GPT-3. And it has nothing to do with what we're doing. I hope that answers the question.
Thank you. Connor, a question that was asked before this even started on our sign-up form. How will training NeoGPT work in terms of cost? The OpenAI training of GPT-3 took millions of dollars. What will Eleuther AI do different from that?
Yeah, so we are, I am one of the oldest members of the TensorFlow Research Cloud, which is a program you can all sign up for. They're really nice people, where they give you access to a bunch of TPUs basically for free because Google apparently has money to burn. Don't ask me. I have met the people I tried with them and I've asked them straight face, how the hell are you giving me millions of dollars to compute? And they just kind of like shrugged and said, oh, no, that was cool. That was basically literally their explanation. Like, I'm not making this shit up. So we currently have access to a lot of TPUs. We don't have regular access to them, so we have like preemptible access. It's basically if no paying customer is using them, we get to use them. And this has brought us up to like GPT-2 level pretty successfully. So like we have like GPT-2 models that have pretty good performance and such, and our code should scale, indefinitely to these higher levels. We are not currently sure if training an actual GPT-3 size model will be possible for this exact reason. If we would train it on the kind of hardware we currently have access to, it is possible, but it would take like a year or something like that. So we might do that just for shits and giggles, just for fun, if that is a thing. The other thing we might try to do is once we have working code and models, just ask Google nicely, hey, do you have compute laying around? Do you want to do this? Perhaps.
Thank you. So I'll ask another question or two from the list because a lot of wonderful questions. But
actually, sorry, could I just quickly address this because this is important to me? So the reason I think Graham's question was not in good faith is because it's trying to say it is a straw man. It was a straw man argument. I never said anything that said I would advocate genocide. It is, I think, extremely obvious that I am not in favor of genocide. That genocide is one of the worst possible things that could happen in the entire fucking world. And it is a truly mind-boggling thing to me that one would consider even thinking that might be something I think. And therefore, I'm saying that this is a bad faith argument. This was not meant to actually ask me a question about information. This was an emotional, a blue team, red team type attack towards me. If I've misunderstood you, Graham, I apologize, and I am very happy to apologize to you and to re-ask your question. But I would ask you to please not assume something as harmful as that if you and instead engage with me in open, charitable discussions. Thank you.
All right. Thank you. So Connor, I'll ask another question or two that people have shared with us. It's been an hour and a half, a wonderful hour and a half. So after we do a couple more questions, we'll break up into video chat rooms, and then we can continue this discussion with each other and with Connor, of course, participating as well. So Mr. R asks, if the hypothetical GPT-N were to achieve human performance on all the benchmarks that GPT-3 was tested on, would that be an AGI? Would it be a transformative AI?
So I specifically did not get into defining intelligence in the talk because that is a talk and a half in itself. Everyone has their own, their own 2 cents to add here. And so I was loose with the words I use in the talk. This is not what I would use if I would be writing a paper or something. I would be way more careful about how I define my terms. So I would instead, so I like the word transformative AI. I think transformative AI is a really good term because it doesn't try to attribute any type of intelligence or something to it. I like that term. And the way we would define it then is basically through the sense of economic value. So I don't think there is a sharp line between AGI and not AGI. Like there is never going to be a sharp line. No benchmark is ever going to be 100% satisfied. So like for me, like in my day to day, after 2 beers with my friends conversation, I would consider GPT-3 to be a limited modality AGI. It is general, it is intelligent. It can do it has learned many general tasks in a certain domain. Can it do everything? No, of course not. Because GPT-3 was not I think it's incredibly silly that some people, for example, ask GPT questions about the physical world and say, look, it doesn't understand that elephants are bigger than mice, so it must be stupid. But that is very silly to me because GPT-3 was trained on its universe of text. Its universe of text has its own kind of physics, the same way our universe has physics. Our universe gives us input data in the form of it's like 3D environments, while the model has this kind of 1D text-based physics. And if you define AGI in the François Cholet type way of this generalized ability to learn over different domains, then transformers have shown they can learn over the physics of text, they can learn over the physics of images, they can learn over the physics of audio. So at some point, it just becomes kind of semantics, whether or not you say, okay, this is AGI, this is not AGI. It's not super useful, in my opinion, to think of it that way. It's more, again, it's like we're in January and people are saying, oh, okay, 10 people in China have the flu. Big deal. I've had the flu before. It's not that bad. That's what AGI feels to me like now. It's like GPT-3 is not going to take over the world. I feel very comfortable saying that. If it does take over the world, well, fuck me. But I generally don't think that. I don't think it is a agentic AI, but that's what I tried to show with this like weak reinforcement learning agent with a strong reinforcement learning model. Is that I think that this is the basis. This is the first step towards creating such very strong AGI. Well, not the first, like the 10th step, and we should be taking this seriously. But again, I might be wrong, but I can only make my case, and it's up to you to decide whether my arguments are convincing or not.
Thank you, Connor. I invite everybody to unmute now and clap. And even if you have not unmuted, Connor, pretend that everybody is clapping. So thank you very, very much.
Thank you.
Thank you. Okay, so thank you, everybody. And it is not over. We're going to go to small video chat rooms. Feel free to move around, especially as the evening moves on and all the best parties end up in the kitchen. So, you know, you can join up into whatever meeting room you want. So you see here that there's a link, which I will share again. Jitsi does not require installation or login or anything of the sort. It's quite straightforward to use.